Hi, and welcome to this video about a paper I wrote for a few weeks ago, which is about the rotation of the moon. If you do not know anything about gravity or the rotation of the moon or about orbiting other objects, you might need to check that out before continue watching. The paper I wrote is all about the main theory of the rotation of the moon is that the moon is rotating around its own axis in such speed that it will show the same side towards Earth all the time. But I don't think that this is what's going on. I think the moon is not rotating and it's showing the same sides towards Earth because that's the natural path for any object in orbit. Okay, so just fast recap, like if you have a central object like this and you have an object orbiting in it, the object in orbit is traveling from this position by having a velocity in this direction and the force pulling it down, and it's slowly moving, changing a direction of the velocity due to the force, and it's moving over here. That is how an object is orbiting another object, according to the old view of things. According to my view, this is not what's going on. But first, explain how this will impact an non-orbiting object. If I have this non-orbiting object, it will slowly move like this and eventually be over here. As you can see, it has different size towards the central mass, and that's logical because how the theory predict an object orbiting, because you have one speed component and one force down, and it's slowly shifting its direction of the speed. But I don't think this is going on, and I'm gonna explain why. If I have a non-rotating rigid object like this, one is falling from this object to this. We don't know which path here is pointing towards the central mass, but we don't really need to in this example, because think about the next object, like this. This is two identical objects. They will of course orbiting from this position to this position. They would. That's the only sensible thing. And if I move them a little bit closer, they will be a little bit closer. But they're still all orbiting in their own orbit. And I move them a little bit closer, a little bit closer. And here it's like it's showing the same side. But of course, it's two objects, so maybe you can explain that by somehow. But if I have another one here, I have then an identical object as these two objects, but they are glued together. Then, according to the theory, they will orbit like this. Because, they have a speed component and a force down, and it would show a different size towards the central mass. But when it's two separate objects, it will move like this. For me, this makes no sense. Like, the nature doesn't have like an perspective of what is really an object or not. It has no perspective about, oh, now we became two spaceships instead of one, then we need to orbit in a new way. Of course, nature doesn't do that. So according to me, the only sensible way for this to orbit is like this, and then showing the same size towards the central mass all the time. And the reason why I do it is because I don't believe that like what's really going on, that this object is orbiting around the central mass due to some force pulling it down, because we don't really believe in Newtonian mechanics anymore. We believe in general relativity, and general relativity says that an object is orbiting around a central mass due to that the central mass is curvating the space. So what I think is going on is that this spaceship or moon or whatever it is, satellite, is moving in a straight path in a curved environment. And you all know when you're moving in a straight path, you will always have this, unless you are rotating around your axis, you will have the same part of you pointing forward. And that's what I think is going on. And there are even more reasons to believe this. If I move this and look at this, this is a cloud. This is some kind of gas cloud or a lamp of gas or something. This gas cloud will of course orbiting like this, showing the same sides towards the central mass, because it can't moving like this, because this atom over here, they are not, because it's a gas and not a rigid body, this atom can't really know that they should start moving in a wider orbit, and these ones, knowing that they're going to orbiting in a closer orbit, it will of course orbit like this, every atom for itself, every atom orbiting in its own path. And that is what a gas cloud do, and I think a rigid body should do the same, every atom moving in its own orbit. A good thing with my theory here is that it makes predictions which are different from the prediction of the old idea of the rotation of the moon. So if you have a satellite like this moving here, it's moving in free space, moving a non-rotating satellite, for example a human-built satellite or an asteroid or anything, having as one point pointing forward. For some reason this satellite is coming close to central mass, like a Jupiter or Mars or something, and it passes by. The old theory predicts that if it's just passing by, it will come here, falling in orbit, and come out from the pass by having a new part of the satellite pointing forward and a new part pointing backward. But my theory predicts that because it's moving forward in a curved environment, but still it's moving in a straight path, it will have the same side pointing forward. This one should be quite easily done. It should actually really have been done already, but I have looking for evidence for this kind of experiments, but I haven't, or observations, but I haven't found any one. And unfortunately, I don't own a telescope or I don't own a spaceship by myself, so I can't really check this out. I hope someone else can for me, and let me know what you find. Another experiment which you can do, but you need two spaceships, identical spaceships, and I don't have two, but if you do have them, you can have them. You have them orbiting like this, one after another, like this. From seeing they orbiting like this, you don't really know if they are orbiting in a straight path or if they are falling in orbit and rotating. Like my theory says they will be non-rotating, but the old theory says they have to be rotating to show the same side. But we don't really know. But we can check this, because test this, because if these two are connecting to each other like this, if they like have hooks going out and connect, according to my theory, because they are just moving in a straight path, and just because they're connecting will not change their momentum or anything, they should just continue like this. But the old theory says if they will not continue, they will start to showing different sides, because the speed or the angular momentum this individual part has will not be enough for this common, for this when they are one object to rotate anymore. And the reason for that is because to have inertia enough, you need to have an angular momentum enough, you need to have enough inertia, but you will not have, because inertia is depending on the distance for each part to the center of the object in squared. So it will not be enough. So this will start to show different side. It will not have time to rotate as much, so it will show like this, and then start showing different sides towards the central central mass. You can do it opposites. If you have one object moving like this, showing the same size towards Earth all the time, and if you disconnect them, my theory says that they will show the same size towards Earth still. But the old theory says they will then have too high angular momentum, so they will start to rotate too fast. Oh. Okay, this isn't, yeah, doesn't matter. You get the point. So there is like two different ways to observe or test my theory compared to the old Newtonian theory, which most people believe in. I hope to hear from you. If you want to read this, where I have maybe expressed myself a little bit better, or if you just prefer to have it in text instead of in a video, I will put it down in a link below somewhere, and then you can download the paper and read it. I would love you to come back to me, like send an email or something, and let me know if I missed something, or if you think that I'm wrong and stupid, or if you think I'm right. And yeah, thank you for watching.